All right, CNT140, Chapter 9, we're going to pick up where we left off. Your cable TV links are typically using your 1310 or 1550 nanometer over single mode fiber for distance reasons. Computer networks, standardized on IEEE 802.3. We're typically dealing with Ethernet networks now. And there again, we're looking at, copper to the desktop kind of thing, fiber between closets. And a lot of our interfaces now are based on these SFPs. Think about earlier this semester when we used SFPs to connect two switches together with a fiber link. A lot of our devices have that in that allows us to slide in the SFP we need for the standard we need for the distance we need. Okay, as we talked about in our fiber links lab. So allowing us to do the connection between here or connection out to a desktop or media converter like we have right here. Most of our desktops and laptops have a copper port in, so we would plug into a media converter. Media converter would give us the fiber link back to the main closet for fiber to the desktop. With our closed circuit television or security systems, a lot of times we're dealing with especially in large buildings, distances. So there's ways that we can use converters to get fiber out to a camera at a pretty good distance using these media converters. Industrial sites a lot of times use fiber optic for noise immunity. In many cases, have been doing for many years, and usually graded index multimode fiber, giving large distances. And some are even using your plastic core fiber, in some cases. It's important for the end user and the contractor to discuss the actual application because that'll drive what is needed. And the applications covered by the standards. The data applications are covered by your standards on what you need. What kind of connection do you need? What kind of SFP kind of thing you need? So, for one of the things that needs to be done is planning the route, especially when we're dealing with outside. Inside too, you need to plan where the cable's going. You need to determine the cable plant and the hardware, and every installation will be unique on how it's dealt with. There's a lot of similarities, but everyone's going to be unique. Where it's going to go, local building codes and laws, individuals involved in the design, and your premise and outside are different. Premise can be pretty simple. I can get an architectural drawing of the building, have a pretty good idea, look up above ceilings to make sure there isn't obstacles you're not aware of, plan out your cable trays, plan out your routes for interduct, and fairly simple, fairly straightforward, again, using CAD drawings. Think back to our bid spec that we're doing. We have a blueprint of the building, and that gave us a good idea to be able to figure out a lot of things out that we would need for the design. If the building's in the design phase, there's a lot of possibility for input and maybe even, hey, can we have this installed while it's being built kind of thing. Pre-existing, I need some drawings and kind of work around what's there. And now you have to start thinking about working around what is there. With outside plant, the route could be very long and involve many things that you're dealing with. Crossing along open fields, along roads, maybe going under roads, maybe dealing with rivers and lakes and streams, and sometimes it's a combination of all of those. So we could be having buried cable, aerial, underwater, in some cases all of those till we get from point A to point B. So it could be an interduct, it could be buried, it could be an aerial cable, might even be underwater. Again, all those things might be part of it, or a combination of those things might be the pathway. So a lot of times with outside plant, you're dealing with other data like GIS data, geographic informational systems. So you're now looking at maps of areas that have data embedded in them so you can start planning out. And here's an example of a Santa Monica city and showing some of the links in here. And I'm going to guess maybe some are in place and some are planned by the color code. But you're now looking at city data, city maps to know what is there pathways there that we can use and maybe utilize and or rent kind of thing, or do we need to determine our own? GIS is limited, You know, you have a lot of information available there, but I can't tell some of these things here. What kind of soil do I need? Is it a rocky soil? Can I actually bury in it? Do I need to trench and put a conduit in? What do I need to deal with? So GIS is helpful, but you still need a site survey. Basically walk along the site to figure out what you're dealing with. Site survey should be doing as soon as possible, and you're literally going to go to the site and observe where it needs to be put in, or walk along the path that's going to be used, or maybe even drive along the path to know where it's going to be installed, to know what you're encountering. And in cities, as you said, there might be available conduits or spaces on poles that you could route cabling. So that might be something that has to be researched. Is there stuff available we can use in a city, or do we need to run our own? So as soon as possible, visit that. In a premise network, we should look at where all the, look above the ceiling to know where the trays are going to be put, see obstacles, take pictures, that sort of thing. Again, if it's under construction, you might have a little bit more options on what you can do. With outside plant, start with a good map. Again, Google Maps kind of thing. Use some GIS data, and that'll get you maybe a lot of the pieces you need, and then you go walk the route. Actually walk the route, taking note of what you're going to encounter, what kind of soil you encounter, hills, those sorts of things. For the install, you need a good map, and what permissions do you need? What kind of areas are we running through? Do we need permits? Do we need permissions to do this? It might be local, state, and even federal authorities, and it takes time to get permissions, and you'll usually need detailed plans to share with them, like, this is what we're intending to do, and then they can, give you the thumbs up or the thumbs down, or maybe tell you, well, you can't do it that way, but using these guidelines, you can do it this way, which might need some redoing to figure out what you're going to do. And in some cases, places might even have fiber that you can rent, and you would not need to install anything new. Okay, so with your outside plant install, unless you're working with, unless you're doing work for a utility, has somebody already that has the contacts, you might need to plan an adequate time to make contact and get approval for anybody that's involved in this. They remind us of when we get to the point of looking at digging for trenching, whatever. There's sites out there, there's utilities out there where you check before you dig to make sure that you're not crossing any kind of utility paths or digging up a utility. Last thing you want to do is dig up a sewer line and have to repair that whole mess, if you will. So there is sites out there where you can say, this is the plan, this is the path we're going for. Please let us know if there's any utilities here, and they literally will come out and start marking with flags, indicating what is in that area to know what you're avoiding. Choosing the components first, again, along with planning the route. When we know where the cables are going to be, we now can look at where things are going to be spliced, and where the cables might be terminated, putting in a splice case, those sorts of things. Those sorts of things can now be started to be figured out. Always start with the choice of the cable, and again, the type of install. What kind of install, what I need might drive the type of cable we're going to use. If you're doing a direct burr, you need a certain type of cable. If you're doing aerial, you need a different type of cable. So once you know where it's going, now we can start determining the type of cable we need for area, and then what splicing together will look like going from this type of cable to this type of cable. Underground cable is generally installed in conduit. These are usually designed for high pulling tension to pull through the conduit. And then periodically, these cables are usually spliced together. You pull so far, splice together, pull another line so far, splice together, that sort of thing. So you need to have room to do that. And this even shows you the idea here. I pull cable, I might do a surplus here, and then continue the pull. But I might pull from here out this way, and then from here out this way, and then splice together here. There's different options for doing that. You need to make sure there's room on the ends or wherever you need to splice, so you have excess cable to pull up into a splice trailer where you splice those together. And then when I'm done, I need to make sure I have some sort of protection for those splices, whether it be a pedestal above ground where you do the splicing and then cover, or a vault in the ground where your splice is in there and then it's covered up with a utility cover, if you will. Direct burial you can place without any conduit, but I need to make sure I have the correct type of cable to do so. So I might actually be doing a trench. And there's more than one way to do it. This kind of reminds you of like a giant ditch witch, kind of like a big saw that you're going to dig a trench in. And then there's a style here that's a plow that you're literally dragging it through, and as it goes, the fiber's kind of getting laid in there. But I now need the correct type of fiber to do so. And we're dealing with the type of armored fiber we've looked at before. And again, when you're done, when you're connecting two together, leave room so you can pull it up into the trailer and splice them together. And then I need protection for those splices when I'm done. Micro trenching is a technique that can get used where you're doing a very small slit, usually not very deep, maybe about a foot deep, that's just big enough to lay some fiber in on top of each other. And we're talking almost like a saw blade, cutting a kerf down through the ground, and you lay your fibers down in that micro trench. And this might go along the edge of a roadway kind of thing. And there is cabling for that allow you to kind of like stack on top of each other to do high fiber counts in a small space. With aerial fiber, I either need to lash the cable to a messenger, lash the fiber to a messenger cable. The messenger cable is basically a steel cable that takes the strain or the stress, or I use a special type of aerial cable that looks like a figure 8 from the end that has the steel messenger already in it. Here's the first style. I might have the messenger cable here, the steel cable, and my fiber hangs below it, and they actually do a lashing that'll wrap the fiber optic cable to the messenger cable, lash them together. That is actually the lashing tool to do so. Or I install a cable like so that has that steel messenger wire built into it, and the jacket itself is like a figure 8, and the it's kind of all enclosed in one. You anchor the steel cable to the pole, and then the fibers go along for the ride, almost acting like a little hammock supporting it. There is a type of fiber optical ground wire. Utilities often use this. The fiber itself, you have a steel cable here that can carry your electrical and or ground wire. And then in the center is a tube where you have your fiber optic in. So that cable is typically up on the very top of the poles and gets brought down to the ground, and you have now data cables inside the ground wire. And we remember that the magnetic fields of the electricity on here do not affect the data on the fiber cables. So a lot of times you'll see this on the very high tension poles. That line running across the top is actually usually has data lines in it. Underwater, I now need cabling that will withstand the depth as well as the water. So now we're dealing with cable that's specially designed that in many cases lays across the lake or ocean floor, and installing it does require special ships. Here's a ship that actually has that fiber cable spooled in there, and it slowly feeds it out. It actually pulls a plow through the lake or ocean floor, and then the fiber cable kind of gets put in that little trench and covered up. Our outside plant, and that's actually your underwater cable there, sorry. Your outside plant, some of these can be made to order. Some can be made to order, can save costs. But a lot of times your outside plant is long distances, so you're literally laying the fiber. When you have excess at the end, pull it out, splice it, seal it back up kind of thing. So there is some that can be made to order for maybe shorter distances, but your longer ones are typically as we were showing earlier. Outside plant, choosing single mode fiber is easy. Basic 1300 single mode fiber for longest links using wavelength division multiplexing. And your wavelength division multiplexing might be actually using some of these frequencies in here as well. For premise cabling, we're typically looking at OM3 or 5125 used for these, couple 100-meter links between closets in a building. Including more fibers in the cable when you're installing it or designing it does not increase the cost a whole lot, but gives you fibers for either expanding or replacing if there is a failure. You do have additional splicing costs and termination costs on these, but it's usually kind of outweighed with not having to dig up and retrench and put more fiber cables in later. And if you remember when we picked out the fiber for even our premise cabling, we spec'd out a couple extra strands that we would have for either upgrading or doing upgrading in the future or having multi-runs for redundancy purposes. All right, we'll come back in the next podcast and keep on rolling.